Thanks for coming today. This is the campus at Horton, or we also call it Horton Plaza. It's a project we've been working on since 2018. This is one of the largest projects in Miyamoto we've had. It's a $350 million construction cost, and we've accumulated about $1.75 million in fee. And we actually have a possible phase 2 coming along, which is another almost $1 million portion of the job. So it's a very significant, very interesting, very collective job that we've done. So today I'm just going to kind of talk about kind of just some overall stuff about the project. And then there's been some very interesting and unique things that I would just like to kind of show everybody about what we've done and what we've learned from this job. This has been a really big inter-office effort. It's not just, I mean, this may have a San Diego project number, but we've had at least 38 Miyamoto employees working on this job. We've done, I think it might actually be over 14,000 now. I think we may have just passed that. And on this, and working on this, and we've actually had at least 10 offices. I hope I didn't miss somebody, but here's all the offices that I know contributed to the job, which is a lot of a lot of them. I just wanted to kind of mention our clients and partners on the project. Stockdale Capital Partners is the property owner, and they've been very involved from the beginning. RDC, or Retail Design Collaborative, out of LA, Long Beach. They're the executive architect on the project. Turner Construction is the general contractor. SME Steel, this job is all steel, so they've had a huge portion of the job, and they've actually been really good at it. And then they've worked closely with Corbrace. The mechanical engineer and electrical engineer is Integral Group. And then TSSI has done concrete, and then also in Rios and EYRC Architects out of the LA area. They've also done a bunch of work on the job for design, aesthetics, that kind of stuff. This has been a very interesting job for me. There's been multiple news articles, even people protesting and stuff about changing the project. So it's actually, you can look up, you can just go and type Horton Plaza news, and you can find just a whole bunch of things, people complaining, people loving it. It's been a very interesting thing. And it's also been political. They've had city council and mayor involved, all kinds of stuff. So I just wanted to kind of.
I was going to add, that's really funny that people complain about it, because when it was the previous version, nobody went there and nobody seemed to like it. So it's just funny, the nature of people, to me.
Yeah, a lot of people in the architecture world felt that it should be considered a historical building. It definitely doesn't meet the historical criteria. You know, there was a big push to try to get it marked as a historical building, so we couldn't do any of this stuff to it.
And it was ugly.
So just real quick, I kind of want to tell everybody kind of what the existing building is. It was built in the early 80s. Most of the construction happened in 1984. It was designed by an architect, Jardy. He did a lot of very, flowy, designy, all these projects that all the engineers hate. And then Robert Engelkirk was the structural engineer. It's over 1 million square feet. It's a huge property. It's a very well-known center of San Diego. If people have been to San Diego, downtown, you've probably seen it. Anybody from San Diego knows exactly what I'm talking about when I say I work on Horton Plaza and stuff. So it's something that is a very, everybody knows about it. And that's probably why it's been in the news so much too. It was made of all steel construction, pre-Northridge moment frames, which we all know are not the greatest system in the world. And generally it's been 5 stories. One exception was something we call, one part of the project we call Building A, was retrofitted in 2009 with buckling restraint braces and stuff. And that will become important later on when we kind of talk about that area. So this is a like a Google Earth view of the area. You can kind of see it takes up about a 3x2 block chunk out of downtown. We've kind of broken the project up into kind of 4 areas. The red area we called campus. And that's the main part of the existing mall and everything. And it's very spread out. There's an area called park, which we had some scope, but it's not very relevant to this conversation. So we're just gonna leave it there. There's parking garages on the site. They actually have the largest parking count anywhere in San Diego. And then also in the very bottom of the screen is in the green is called what we're calling Building A. It's where the old used to be a Nordstrom's in there. And that was the piece that was retrofitted. You'll notice that this is right in the middle of downtown. There's not a lot of land, you know, around to do, you know, anything with. Build new buildings, have lay down areas, anything like that. So what we've been doing on the project is, I think Jeff kind of alluded to this, but the existing building has been kind of decrepit up until we started construction. The Westfield shopping malls owned the property prior to this, and they basically just kind of gave up on the property, stopped renewing leases. It turned into basically a giant homeless camp. And people just basically use it as a thoroughfare and sleeping for the homeless. So when we started the job, I think there was 6 tenants left. When we started design, and by the time we got into construction, there were none left. So so the idea was to revitalize and modernize the site. A big thing was they don't want the mall scene downtown. It hasn't been lucrative for a long time. So we're changing it. They're changing it to generally office and life science. With that, they wanted to change the flow of the occupants. The existing building has bridges and stairs going in strange places. It was something where if you visited the site, you got lost. And the rumor is that was on purpose. They try to get you in, you get stuck there and have to buy your way out. Go into every store before you could find the exit. So all of these bridges and stairs and weird pathways have been completely gutted, and we're adding in new elevators, new stairs all over the place. So it's a very, very like heavy TI. And one of the big things was adding square footage. I just want to kind of show, so this is what the project looked like before demolition started. And it actually was this empty. There was like nothing left. This is what it looks like today from approximately the same view. And you can see a lot of stuff has been gutted out. All the mall walls and everything have been completely gone. A lot of there was this little tower and truss and everything. Those are all gone, being opened up into a big area. And this is what it's going to look. This is a rendering of what it's going to look like when completed. Here's another view. This photo was taken back when the mall was actually still kind of going. So there's a lot of people in stores there. This was probably from like 2008 or so, I would guess. This is what it looks like now. We've actually, there's kind of something like in the corner, you can, the first picture, there's a big triangle that was removed. A lot of stuff has been taken out. You can, if you look closely in the back, you can kind of see bridges and everything. Those have all been removed. And this is what it's going to look like in the future. Notice these are all, a lot of planting area and stuff, which seems easy enough, but then you realize that this is actually the third floor of the building, not the ground floor. So adding a lot of weight to a structure that was not meant for that was one thing that we're dealing with. So that was, yeah, so landscaping on elevated levels, we've done a lot of this. We've had a lot of beam strengthening, column strengthening stuff to account for, 3 feet of soil in a tree in a lot of locations. We changed a lot of edges of buildings, where the buildings start, where they stop. This has caused a lot of things like what you see in this diagram here, where we have an existing beam and we're putting a gigantic WT on the bottom because we're taking an existing just regular beam and turning it into a transfer girder. We're dropping a column right in the middle of it. This one in particular was a 60-foot long beam that is turning into a 3-story transfer girder. So we basically have a 3-foot deep WT at the bottom. We had to do some frame retrofits. This wasn't a retrofit project in particular, but we were doing the 10% game where we changed some stuff by more than 10%. We retrofitted frames. I think there was like 10 different frames were retrofitted with just the connections. Everything else was sufficient. So I said we added a lot of elevators everywhere. None of them were in very convenient spots. 3 elevator pits are actually on raised floors. So we have a hanging pit below. And usually we don't care about the elevator pit loads because we're on grade, but when we have a raised elevator pit, they're very significant. So we had a lot of strengthening to go here, to go that kind of stuff. We actually had issues about even locating a lot of these because we would, they would pop down into spaces for tenants. We had a lot of columns, new columns landing on existing beams. We had to strengthen what we're talking about over here. We also had a lot of demolition and re-support, sequencing issues. Going from, hey, we had to pull back the deck, but the new edge of deck is halfway through a beam span that goes all the way along the building. So you gotta basically shore up the entire edge of deck and the ends of the beams, cut all that off, come in and add a new beam across there, add new columns, and then you can take the shoring down. It's actually been a very logistical, very big logistical problem for shoring and everything like that. We had a bunch of new openings, infill openings like a lot of TIs do. They were all over the place. So a lot of times it was hard to keep track of. So one thing that we wanted, or the clients wanted to do, and we actually completed the design of, was a sawtooth roof. Some of you have probably done sawtooth roofs before or in concept, and I know I think this is the 4th or 5th one I've done in concept, and then it just, everybody realizes it's way too expensive in seismic country to get this to work, and then it gets value engineered out. This one, we went all the way through design of a sawtooth roof on an existing building. So below the sawtooth is actually the existing floor level. We actually were saying, oh, we can demo out all the old existing roof and put this in. We got all the way through permitting and everything, and then it was value engineered out. So we do have a lot of details and stuff. If anybody ever needs to do that in the future, this is the project where you can come and steal them from. But I kind of wanted to show you guys how we did this. The green here is the existing moment frames in the building. And we had to keep those the same because they were already existing. We didn't really have any control. We couldn't add new locations for it. But what we did is there's all these blue columns in this diagram. They were really large. I think they were like 12 by 12 by 5/8 or something ridiculous. And then all the pinks they weren't quite that large. I can't remember exactly what they were, but they were big HSSs as well. And basically the pink beams and the blue column pieces acted as like Varendeel trusses in both directions. As you can imagine, this got to be very expensive, and that's why it didn't work out. But it worked out really well about how we did it in the end. One interesting thing about this was that to try to avoid putting lateral load anywhere that it wasn't intended to go into the frames, we actually basically had, you'll notice that a lot of the blue columns kind of land on these little spindly little other columns below. So we're actually doing those as gravity only connections, and they actually have a pin at the top of the column there to allow a rotation. Another thing on this job that was a big pain, and I wanted to mention it to everybody, was a Zonolite roof. Zonolite roofs were all the craze in like the early 80s. What it is, it's a really thin deck. This one in particular was a 22 gauge deck that was 1 3/8 inch thick. And they put this Zonolite concrete. It's like an insulating concrete. It's like about the same density as water. They put a little bit of layer in the bottom of that, and then they put this, just an insulating foam. It's like, in this case, it's like 3.5. You can see in the diagram, and then in the picture is where we have demoed that. So you can see all of the foam kind of wired together in there. And then on top, you have another layer of this Zonolite concrete, which is like 2 inches. This has been very interesting about how because we had to put a lot of big units up on the roof to make this work. So we actually came up with oddly enough, the most cost-effective thing to do was to remove the Zonolite on top and the foam and shore the deck, and then fill it with a concrete topping and strengthen the beams as required. We actually went through a couple of iterations of doing, just rip out the deck and everything, but apparently this was the most cost-effective. I thought that was very interesting, because this Zonolite roof is really crappy. It doesn't have any kind of, you can't anchor to it. You can't put anything more than like a person on top of it, and it has almost zero shear capacity for a diaphragm. So that was kind of what we've done doing on campus. There's some interesting things here and there, but I wanted to talk about, I know the eagle-eyed of you may have noticed that I said earlier something about adding square footage. And there's not a lot of room to add square footage on the job. So this is a very condensed version of a conversation that we had, the design team and ownership had over the course of a couple of months. The owner asked, how can we add square footage? We say, what about adding a floor to a building? That was brought up. And the owner says, how about 5 more floors? And we say, well, we could figure out that we could actually triple the height of this building. And they said, no, we don't go quite that high, but let's double it. So that's what we did. We looked at, so the existing building is a 5-story steel building that was definitely not meant for it to have stories added to it in the future. We actually looked at adding up to 10 stories on top of the 5-story building to make a 15-story building total. The owner, we actually kind of found that the sweet spot for return on investment was actually about 13 stories for this particular building. For whatever the reason, the owner didn't want to go quite that high. They decided on 10 plus a occupied roof. And so that's what we did. Now, this is understand this is a very atypical thing to do. And a lot of you are kind of thinking like, how in the heck did you guys manage to do that? So that's what I want to spend a lot of time on here, talking about what we did here to make this happen. One thing that made this economical, I think, was luck. So this is an architectural plan of the building. Originally, back in 1984, the building was made with non-ductile moment frames, and this is about where they are located on the architectural plan. In 2009, it was retrofitted with buckling restraint braces, and those are shown in the purple here. So when the 2009 happened, basically all the blue moment frames were abandoned as lateral system. But because the columns and footings are much, much, much larger than it would need for gravity, those were actually already pretty decently sized to accommodate new floors. So what we did is in the green area, we strengthened columns and footings. We added 5 new columns and footings in red. And then we also, I didn't point it out here exactly, but we also strengthened the columns and beams and such for the brace frames and added micro piles. So this is one of the brace frames that we have. So here, these are 3-inch diameter rods that I think they went in 120 feet, I believe, was the longest one on the left here. So they had to drill all those down. And then we added these gigantic base plates. And you can see on the right here. And you can see a person in the back for scale. These things are massive. I think the thickest plate we had on some of these were 3 inches. And they had a lot of welding to do. They welded all these in place in the field. The base plates kind of served like a double duty for the micropiles. It's one they helped for uplift. But also, here's a view of a finished one. But also some of the footings had to be, strengthened, widened a little bit, but some of them didn't, because the bearing area was sufficient for what we needed. But we often had punching shear problems, such like that, or flexural problems, and we could actually get, if we basically made the base of the column a lot wider, we could justify the existing footing, especially the bottom reinforcing where we needed. So we didn't have to add any kind of bottom reinforcing through the column or under, or through the footing or underneath or anything like that, which can be very, very expensive and difficult, and if it even works at all. We also had to do a lot of column strengthening. It makes sense. The columns are designed for half the load that we're putting on them now. A lot of times when you do column strengthening, you have a W shape and you put a plate on each side of it. You take out the buckling. However, here we're not adding 15% of the load. We're adding over 100%. So we actually had to continue the plates through the floor system, through the deck, so that we actually had continuous new amount of area. Some of these columns went up by like three times what they originally were for just gross area. One of the things that was really interesting to me about this was getting the plates through the floor. You had to actually go through, you had to go around the shear tabs in the beams. And so here's a couple of pictures where you can kind of see, like, we actually had I didn't have any pictures of the slots, unfortunately, but we have a slot through the plate, top and bottom. It would go through either from the top going down or from the bottom going up, and then weld to another plate on the other end. And then we would have to close that off with a closure plate here so that we didn't have a big open area with a hole. Some of these plates, I think some of the biggest plates were like 2.5 inches too. Some of them were massive. We also, so at the location where the existing building stops and the new building starts was a very interesting one. Here's a couple of pictures of how this happened. Well, for one, not all the columns fit completely centered on the column below. That was actually taken out into account in design. We actually had some additional moments due to the eccentricity of the columns. But basically what we had these giant cap plates on the columns that would serve as base plates for the columns above. Some of these were a little uncomfortably large eccentricities, but it all worked out. You can actually, if you kind of look really closely at the picture on the very left, you can see that it actually kind of looks like a really flat, like I shape. That particular column was like a 6x6 tube steel that we basically made into sandwiched 2 giant plates around it, make it into a much larger column. The one in the middle actually was one of the original moment frame columns. So it's, we didn't have any column plating on that one. So that one was just a plate, and then the new column sat right on top of it. And then the one on the right is actually a brace frame column. We actually had to plate over existing plates and then plating both sides of the brace frame column. So there was like, kind of like 3 layers of plating on some of those. So this is actually like a view of this building A after they ripped off the roof. The roof it was kind of a weird shape, so I had to take off the roof of that during construction. And then here's a fairly recent picture of it. You can tell it's much larger. So I just wanted to go over a bunch of lessons learned, both from just the project size and some of the interesting things that have happened on it. So we were asked to do demolition drawings, which I don't really want to do again. It was an interesting thing. We had specifically said that these are for reference only, that they shouldn't, be used without consulting the regular construction documents. And the demo contractor ignored all of that pretty much. So because we had demolition drawings, they were, there was things like, oh, well, you didn't show this 2 foot by 2 foot duct opening on the demolition drawing, so we didn't cut it out. There was a lot of stuff like that. The demolition contractor used it in a vacuum, and it's caused a lot of issues. And there's also stuff, like we basically showed the demolition drawings just basically from what we did in Revit, and didn't really spend any time annotating it and stuff like that. So I'm going to recommend that if people do demolition drawings in the future, that you spend some good amount of time going and annotating and calling off notes and stuff, exactly what is happening at locations. We had a lot of problems with the landscape architect is going crazy and putting 8 feet of soil on the roof at times. There was at one point where they had basically the building A thing where we're adding the floors to, they had like 2.5 feet of soil plus trees. And everybody was confused about why we had basically the same amount of strengthening everywhere as if we had a 15-story building. It was something like where a couple of us understood that early on, but didn't really raise the concerns, and that caused a lot of redesign down the road because the owner couldn't afford that much strengthening. So they had to cut back. We had to redesign and cut back a lot of the landscaping that they really liked. So this is a big project, lesson learned. Big projects, the project manager is stretched very thin when they're looking at stuff. So we actually had we split it into basically kind of 2 pieces, this project. We had Charles in San Francisco basically was kind of sub-project managing the building A portion, and that worked out really well. I was able to do, coordination and stuff project-wide. Then we didn't have that on the campus half of the project. And it was really difficult to get everything sorted out that way. So, it's, really good to have somebody senior on different pieces of the project, apart from the project manager in general. We had an issue with cambering, not camber. We didn't camber some long spans. It wasn't necessarily it wasn't a code issue or anything like that, but there was a bunch of concerns once the project got built, that there was like, oh, there's water ponding on the things, and like, well, we're meeting the deflection criteria, the vibration criteria, but it made some people uneasy. So in the future, we want to make sure that we make sure to camber anything that is long spans. One thing that we did really well in this job as for us at Miyamoto and the design team in general was we spent a lot of time early on figuring out how we're going to label drawings, label floors, that kind of stuff. This project was very large and complicated. I think we had 8 sheets per floor for just for the campus. Or so maybe it was 10 sheets total if you're including building A. we ended up having a really good system about how to label each drawing and everything like that, so it could be found fairly easy down the road. It wasn't this it's still a very complicated set of drawings, but it would have been a lot worse if we hadn't spent time early on doing that. Some additional ones for a project like this, a very complicated retrofit existing building, we did not have appropriate amount for construction administration. I mean, in general, our design fee was big enough that we could, the project budget in general covered it, but we spent a lot more in construction administration than we originally had intended. Something the project this large is, we've gotten like I think for structural alone, I think we're at like 800 RFIs or something now. At the very beginning, we started out with a kind of an idea about, oh, we're going to track all the RFIs and drawings, clouds, and everything like that. That fell through the cracks pretty early, and it's something that I wish we would have kept going, because now it's like you're sitting there like, I know there was an RFI about this area, but I can't figure out what number it was, and you have to spend like half an hour searching and everything instead of just look at the drawings and being like, hey, that's where that came from and everything like that. So we did, I think this is something that we did pretty well, but I think could have been better, is thinking about a lot of this demo, temporary support, and new sequencing stuff. Now, it's not generally, that's a means and methods thing, but it can be very helpful for design for this kind of a project to figure out, like, hey, if we add, does it make sense to add a column first and then demo all the stuff around it? Items like that. Or does it make sense to demo out extra floor so we don't have to temporarily support stuff, floor and everything, then we can just build back extra? Is that more cost effective and easier for the contractor? Existing buildings are definitely worth it. So there's been a lot of talk on this job about whether we should have just torn down building A and built it again, a new tower. And that certainly would have been easier for design. A new building is much easier than trying to add and innovate floors to a building. But the numbers actually worked out. It was less money per square foot for a core and shell to add stories to the existing buildings, even with some of the demo and rebuild and everything like that to it. I think ended up being like $189 per square foot for core and shell versus about $205, I think they said, if it was going to be a new building. So they weren't terribly far apart, but this was definitely a cheaper option. So I was saying, doing innovative things is a lesson learned. Now that we've added the floors to a building, the owner Stockdale keeps wanting to do the same thing with us over and over again. I mean, like this particular project, I think, worked out really well because of the number of items that made this be cost effective. Now they keep wanting to, like, oh yeah, we did it before, we can do it again. I mean, I'm not going to say don't do innovative things, but there's always kind of a drawback to everything you do sometimes. By far the most important lesson learned is don't say no. I think I've even heard Kit say this before, but like a lot of engineers say, no, we can't do that. No, we can't do that. No, we can't do that. the project manager at Stockdale, the owner, actually told me at one point that they actually asked 2 other engineering firms before us about, hey, can we add floors to this building? And both of those said, no, that's not something that can be done. And clearly it is, because we've done it. So it's been really good, because we've tried to, this is a project we've definitely tried to say, yes, we can, yes, we can. It might be more expensive. It might not be very constructible, but yes, we can do that. Both the owner and the architect have said multiple times that they like that we do that. And that's it. Have any questions from the group?
Wayne, I have a question, or maybe even a comment. Can you talk a little bit about all the Revit work we did up front and how that all worked out, and how many hours we spent on that? Because that was an incredible.
Oh gosh, I'm trying to even.
I mean, it was an incredible effort, and it was an incredible learning experience, I think, for us as a group.
Yeah. So that was one of the first, so basically we
is Tesh Paul on by any chance? I didn't see him, but
I don't know. That was something, we spent, so initially we did a lot of concept stuff, but then basically before we did any of the main project, we had 12 different existing building drawings sets. And we had Tesh Paul and the India group go and as-built that. And I think it took like 8 weeks or something for them to go through all of it. I mean, there's 1 million square feet of steel structure. But they basically, every week I got an update of, oh, here's where we're at, here's where we're at. And then actually, I think Mike Vincent did a bunch on that as well. But we had a really, really, really good Revit model to start off with. And it was actually good. It was actually really good because the architects actually would be like, oh yeah, Miyamoto's model is definitely right. Ours is wrong all the time. So we did a really good job. I mean, there was definitely a couple of errors here and there, but for how many pieces we put in there, we had a really good, solid existing building model done.
Yeah, I think that was a really good lesson learned. Do you remember how many hours in total, or about? I mean, I just remember it's just massive hours every week being scheduled there.
Yeah, it was in the like probably like 800 or something.
Yeah,
I mean, this my guess off the top of my head.
Yeah, I want to say we were over 1,000 just to build the model.
Yeah, I know.
Existing model without.
I think Miyamoto BIM India Group did. I think it was like something like 3,000 or 4,000 hours total for this job they put on it.
Great job, team. That's a heck of an effort. So, yeah, hats off to Tesh Paul and Castor for. We couldn't have done this on our own here. There's just no chance. We did not have the capacity, and good job, Eric, for coordinating too. I think the other comment I would make, I think, you talked about the project management piece. I think this is a size project. It probably could have, really benefited from, a full-time project manager, just somebody that's just keeping track of everything, because it's, it's a little bit out of our normal realm where, most of our projects will knock out in 2 months and we'll be done and into CA, but not this one. So
yeah, I was like, that was a big step. That was a big change for me, because if we go back to one of the first pages, like I had been doing projects that were, myself and 2 other people or something like that, or maybe 3 other people. What did I say? There was 38 different people that worked on this job. I mean, that's a lot of, and not all of those were at the same time for sure, but that's a lot of different people that are on one job.
Does that include the specific people in India and Nepal, or are they just
It does. Yeah. I think we had,
Okay, good.
I think there was like 9 different people in India that worked on it. Yeah, I don't know. And this list of offices right here, I sorted that by how many hours were put into it by each office.
And one other comment, since we've done a handful of larger projects in San Diego now, one lesson learned that we've been doing on these bigger projects, because before it was falling on the PM, but was to have a BIM manager that is the lead, that is not just coordinating internally, but having coordination calls with the architect, communicating with the architect, because otherwise that, for this project, it would fall on Wayne to coordinate that, or on Commons, it would fall on John Buckley. So when you're coordinating 38 staff, plus on these big projects, you get about 10 architects that are working on them. When you're coordinating, like Jeff mentioned, a full-time PM, you got to factor in all that, because you will not have anywhere near enough time. So the BIM managing part and having that, like James in our office has been doing that quite a bit now on these bigger projects, and it's been extremely helpful. Because there'll be a lot of times on these newer projects where there'll be the architect will change the floor height and we miss it, or there's a beam floating 4 feet above the floor and the architect can't stand that. They are very, we're doing a good amount of work with Gensler, but if they see steel that's popping out, it drives them nuts. So it's difficult to fake it and make it in the Revit world now, especially when they want weekly updates. So that's been one of the scheduling challenges on these big projects is, the deadline's not for 3 more months. Yes, that's true, but the architect wants weekly updates to coordinate those models. So make sure everybody's factoring in that for these bigger Revit projects.
Yeah, I was like this, that kind of reminds me of another thing. I don't know if I can consider it a lesson learned, because I don't know what to do about it next time, but there was a lot of times, especially early on, where we had, I'd get a call from the architect and be like, why haven't you added this opening yet? And I was like, what opening? They're like, oh yeah, we put it in the model 3 days ago. Why haven't you had your opening? Like, am I supposed to like look through 100 or 1,000,000 square feet of floor every day to find a new opening that you might have added? So I mean, I don't know if there's, maybe on the next project there was something where, if there's some kind of alert system or something that you can set up to get that kind of stuff. That was very aggravating at the beginning of the project.
Yeah. Hey Wayne, DePonch asked through the chat, who is your BIM manager?
So I don't know. I wouldn't say we just had a BIM manager in general for this project, which I think was part of it. Mike Vincent did a lot of the. It was mostly Mike Vincent and India that did the drafting in the BIM work. If I had questions,
our external BIM manager lately on these bigger projects has been James.
Yeah, but for this project in general, we had a pretty good system. I know I was early on, I was talking to Teshpal a lot. But yeah, DePonch, I was like during design, we didn't really have a BIM person talking to the architect, which I think was one of the issues that he was mentioning.
Are you going to present this at SEOC? I don't know if you're down the calendar this year, but next year it'd be perfect.
Yeah, maybe.
The San Diego one would have been perfect since you're right there. But you need to submit this to Excellence in Engineering too.
Anybody else have any questions?
I have a question. Were you able to make profit on this project? And if so, what would you do if you redid this to maximize the profit?
Yeah, so we did. We are in the positive on this job. So I mentioned that we were behind on construction administration. But I think one thing that really helped was this project was very fast. And whenever you have a fast project, it's hard for the architect to do a lot of redesign on stuff. But it also kind of made it so that there was some some design was kind of pushed back into construction.
And
Which then also helps
I can add to this thought too. So
Sure.
our original fee was maybe like 1.1 million. And the one good thing to have in contracts is make sure you have your, especially for these big ones, your expectation of construction duration. That was in our contract. The architect also had it in there as it was Stockdale had an insane 10-month construction schedule, which is not even close. So we burned through that, and right now we're in the process of negotiating $115,000 ad service for, because it's now supposed to go, I think, total of 20, was it 30 months total, 20 extra?
Yeah, 30.
Yeah,
Yeah.
so ending next year. So if we don't get that, we are going to lose money on this project. So that, but having that in there at least gives us leverage to have that discussion and make sure you're having that a few months in advance, because it takes a while to negotiate that. Don't wait.
I was like,
until
that was
6
something
months
that we,
later.
in our proposal and contract, we had a very specific number of site visits and construction duration, and we've surpassed both of those already. So that's why we're able to negotiate the additional fees for these.
And the other thing that would have saved us probably time and sweat is having more on these large projects. We were so slammed, it was difficult to get QA QC reviews, but make sure you're having multiple ongoing QA QC reviews internally by somebody senior, especially with this project, maybe didn't have enough senior people on it. Those are critical. And don't wait until late CDs, have them at 50% DD, 100% DD, multiple during CDs, because it will save you a lot of headache later. Like the cambering thing, if we would have caught that earlier, it was as simple as somebody missed a checkbox on ram steel, so they cambered 40 instead of cambering 1.5 inches on 40 and 40-foot beams. They took them to where you didn't need cambering. It met L over 240, but when you factor in deck deflection, beam deflection, and girder deflection, you're like 2.5 inches of total deflection. It's slightly visible. And if you have floor flatness requirements in your spec, you're not going to meet it. So it's one good thing that what I've been doing now on these newer products is have the engineer take a diagonal dimension from column to column, see what your beam deflection is, your deck deflection is, your girder deflection, and see if you meet, for example, 1/4 inch over 10 feet. You'll find out pretty quickly if you don't have some camber. Once you get over 30 feet, you should start seeing camber.
Even at 30-foot beams, you should typically be bumping up to 3/4 inch camber if they're optimized. If they're heavy, then you probably won't. But and remember our rule. We typically try to camber to about 80% of the dead load, and then a 3/4 inch minimum on camber. If it tells you only need 1/2 inch camber, don't camber it. That's close enough, because the tolerance on camber is plus or minus 1/2 inch. And we did a lot of research in this camber discussion, that we kind of already knew. And it's not a very precise process, but if you're at 3/4, you should be cambering. And if you have any questions about that when you're looking at your projects, give me a call. Great project, guys. Team everywhere in the world for Miyamoto.
Yeah, I was gonna try to thank everybody that worked on it, but it was gonna take like 2 slides worth of stuff. So I'm just gonna say
Really
thanks to
have an
everybody.
hour. Yeah.